Okay, after doing this whole project with the camera not rolling, let's try this again. I will be doing Mrs. Gore's 8th grade semester 2 project over quadratic functions and how to solve them. My equation is y equals 4x squared plus 27x plus 35. And my first method will be solving using the quadratic formula. The quadratic formula states that x equals negative b plus or minus b squared minus 4ac all over 2a. By putting in a, b, and c being the first three, the only three letters in your equation, by placing all those numbers in, it should tell you x when y is 0. Should give you the x-intercepts. So, by plugging in our numbers, it states that x equals negative 27 plus or minus the square root of 27 squared minus 4 times 4 times 35, all over 2 times 4. So I went ahead and simplified 2 times 4, so that's fairly easy. 27 squared, so let's go ahead and get this out of, let's go ahead and solve the square root little thing right there. So 27 squared is the same as 729. Since there is no other negatives to counter out that one, we know this term will be this little part will be negative. 4 times 4 is 16. 16 times 35 is 560. All still over 8. So now that we have this, we can simplify 729 minus 560. This is 169. The square root of 169 is 13. So we've simplified that little part. Now this, because of the plus and minus terms, splits into two different equations. 27 minus 13 over 8 and negative 27 plus 13 over 8. Negative 27 plus 13 comes out to 14. So by carrying over the 8, we have 14 over 8, which also, when converted to a decimal, equals negative 7.5, but we must remember that the numerator is a negative, making this thing negative, making that negative. Negative 27 minus 13 is 40. 40 divided by 8 comes out to a nice negative 5. These are our two answers. So how do we know that these two answers actually do solve this when y equals 0? Well, we can just plug them in. So we still have y equals 4x squared plus 27x plus 35. We are going to be using negative 5 for this example. And if this is true, then y should be 0. So we have okay, so we are going to start out with 4x squared plus 27x plus 35. To complete the square, we have to open up a space right here, and we also have to have something on the other side of the equal sign. So I will do 4x squared plus 27x plus something else equals negative 35. So now we have to get rid of that hideous x. So we're going to divide everything by 4. So this becomes x, oops, I don't need to put a fraction bar there, x squared plus 27x over 4 plus blank equals negative 35. And then we do the other side by 4 as well. So now we're going to have half of this squared, which, so half of that is 27 over 8. And we take that and we square it. 27 squared, as we know previously, is 729. So 729 over 8 squared, I just personally know as 64. So we're going to go ahead and pop this in here. 729 over 64 plus 729 over 64. Whoops, not a 66. I know how to write numbers. And now we must get everything on the same level for these two equations. So now we must take negative 35 times 16. And we've seen that earlier as 560. So 560 divided by now 64. And we're just going to go ahead and pop that right in there. I'm going to go ahead and clear this off for space reasons. 560 divided by 64. And we know this from the previous thing to be 169 divided by 64. And mind you that that is still equal to 729 over 64 plus 27x over 4 plus x squared. Now we're going to find all of this and get this down to a reasonable thing. So now we need to simplify this. So now it's x squared plus 27 divided by 8 equals, oops, I apologize for that little squared. All of this is squared. It is 169 over 64. Now we need to square root this to get rid of that mark. And simply the square root is just that without the squared. For that, but the square root of this, we know from earlier that the square root of 169 is 13, and the square root of 64 is 8. So 13 over 8. And that can be plus or minus. So now we need to solve this. So we take this over to this side. And now we have, and since we can just add these because they're the same denominator, we have 27 plus 13 over 8. 27 plus, I apologize, negative, I'm just going to restart from a little while back. Okay, so now we have x plus 27 over 8 equals plus or minus 13 over 8. Since we are moving that over, we subtract it from both sides. So now x equals negative 27 minus 13 over 8, and because of that term, again, we split it, x also equals negative 27 plus 13 over 8. Negative 27 minus 13 is 40, negative 40 over 8, which also equals 5. So, x, again, equals, well, I guess it's negative 5, equals negative 5, which matches up there. Down here, negative 27 plus 13 is negative 14. Also carry the 8. Negative 14 divided by 8 is negative 1.75. Also found right there. We still have our answers from the previous problem. Okay, so now we're going to be solving by factoring. So first we're going to set this to 0. Now we're going to have to find up find two different things involving that multiply to this and add up to this. Okay, so first what we must do is we have to break this term down into two parts, into two numbers. The first number that 4 can go into, and the second number that second number can go into 35. So 1 into a multiple of 4 and 1 into a factor of 35. Immediately I see that 20 and 7, so I immediately see, this is not always the case, but plus 20 and plus 7, it's not always that the two different little, I guess, words in the word 27 go into. Anyway, I don't know what I'm spewing. And then don't forget, plus 35 still equals 0. We can then think of these as two different little terms that we can both factor stuff out of. For example, we can factor 4x out of this, because there's both 4 and x go into both of these terms. So 4x times 4 plus 5. 4x times 4 plus 5 plus, and from here we can factor out a 7. So 7 times x plus 5 equals 0. It is important when you're factoring that that this term goes in that pretty much that these two numbers are the same. This will be very important later. We can now factor out x. We can now factor out x plus 5 and x plus 5 from this equation, making this 4x plus 7 times x plus 5. From here we know that at least one of these terms is equal to 0. Since the only way to multiply two different numbers, and it equals to 0, that one of these is 0. So logic states that either 4x plus 7 is 0, x plus 5 equals 0. Or logic also states that both of these could equal 0 at the same time, since 0 times 0 is still 0. So, since either of these can be are both correct x's, we'll still set x. We'll move that over. X equals -5, which is to be noted that -5 is one of our known answers. And 4x plus 7. 4x plus 7 is a little different because there is a coefficient to the x, but we can just, since these brackets are just merely cosmetic, we can just divide off that 4. So x equals 7 divided by 4, or -7 divided by 4, since we're moving it across as the equal sign. 7 divided by 4 is also known as -1.75, which is to be noted as one of our known answers. Alright, this is our equation. We need to get this from what's called standard form into vertex form, so we can more easily graph it. So how are we going to do this? Well, first we're going to imagine these little lines going right here. These are parentheses, but they're not really there. I mean, they wouldn't change anything in the problem, but we kind of just group these terms together. The main reason we want to do this is, whoops, there's not an x there. I didn't mean to write an x. Is we need to get rid of this 4. We need to get rid of this coefficient, so we're just going to factor it out. So we can do this by knowing this, and now we actually need these parentheses. Now these are necessary. X squared plus 27 x over 4.
Nope, not waiting too long.
And then we can go ahead and add the plus 35. Since we didn't take anything out of 35 because it's not inside these parentheses. So now we're going to do something that we did fairly early on in the video. We're going to what's called complete the square. So we're going to take half of this, so 4 times x squared plus 27x over 4. And then we're going to add, so plus, and notice I have not closed the parentheses yet. We're going to add half of this squared. So half, we're just easy way to half it is to double the denominator. So plus 27 over 8 squared plus good old 35. Now, now we can make this just a little bit easier. Clean this up just a little bit. 27 squared is 729, and 8 squared is 64. Okay, so now we're just going to bring that little number up there, erase it, 729 over 64. Now, if we are going to add this inside the parentheses, we also need to add it outside here. But we have to be careful. This number is actually 729 over 16 because it's multiplied by 4. So we're going to add 729 over 16 to that. So now we have a perfect square. This simplifies to 4x plus 27 over 8 squared, and then this. I'm running out of space, so I'm just going to draw in a little area right here, and then I'm going to clear my board. Quick little mistake I made. When I added the 27 over 8, I added it again outside the bracket as 24 over 64. I needed to subtract that. I'll fix that in the next scene. Another thing I forgot to do is change this 64 when I had it inside this bracket to 16, since taking it inside the bracket means I have to multiply it by 4. Hence the 16. 64 divided by 4, since it's a fraction, is 16. I fixed this in the next part. Okay, so now we start. Now to start, let's simplify this. So we're going to take 35, whoops, don't need a fraction bar, times 16. So 6 and 5, 3, 18, 1, 0, 3, 5, 0, 6, 5, 6. So, now we know why we're doing that. So, 560 over 16. So now we have 560 minus 729 over 16. This brings us to negative 169 over 16. Okay, so now we can convert these fractions into decimals. So 4x plus, and 27 divided by 8 is 3.375 squared, plus 169 divided by 16 is 10.565. Here is our vertex form, and these two numbers will be used to get our vertex, hence vertex form. Okay, now we successfully have our equation as 4 open parentheses x plus 3.375 close parentheses squared minus, oops, not divided, 10.56. That is the equation we're going to graph. Oops. So now let's So I'm a little pressed for space on this itty bitty tiny whiteboard that I found in my basement. So this is the y-axis and this is the x-axis, outlined in red. All the other squares are marked in orange, thanks to my handy dandy ruler. So now we need to divide this up. We have this equation, but what does it mean? Well, certain things tell us to go up, certain things tell us to go down, left, right, and how the rate in which it kind of parabolas. I don't know if that's a verb. Alright, so now that we know that this equation is 4 times as wide, or steep, or whatever you want to call it, as the father function, now we need to know what these two terms mean. This term determines how far left or right we go. This term determines how far up or down we go. So first what we need to do is we need to find our vertex. Now when finding the vertex, we take the k term and the h term to find our vertex. H being the x value and k being the y value. But we need to modify that just a little bit. All you need to do for that is flip the sign. So it says positive 3.375. We need to make it negative 3.375, and negative 10.56. You only have to flip the sign on this term. You do not have to flip the sign on this term. This is going to be our vertex. Okay, so now let's start plotting our graph. First we need to find the vertex. You can see that I've added just a little bit of our graph here. So we are going to go over negative 3.375 spots. 1, 2, 3, 3.375. About right here. Then we're going to go down to negative 10.56. So about right there. It's hard to be very, very precise on this kind of uneven graph. So now that we have our vertex out of the way, now we need to know the slope of the graph. Okay, so I've zoomed in just a little bit here to make things easier on the eyes. So now we're going to start actually graphing our parabola. Now, I've erased our equation, but I remember it as 4x plus 3.375 squared plus 10.5625. Now, that being our equation, we're going to find what y is equal to when x is equal to 1 over 1, or 1 to the left. 1 to the left being going negative 1 and the x-axis, and since the vertex, the x point on the vertex is negative 3.375, we're just subtracting 1 from it, which is negative 4.375. Oh, I hate this. So then we're going to take negative 4.375 and set it equal to x, making our equation. Setting the equation equal to 4 times negative 4.375 plus 3.375 squared plus 10.5625. We can simplify this to simply negative 1. Negative 1 squared is 1, so 4 times 1 is 4. So now we just have 4. I apologize, that is a minus sign. I goofed up just a little bit. 4 minus 10.5625. This equals, am I still on frame? Yes, this equals negative 6.5625, and that is our y value. And so I will mark that about right there. Now, if we add 1, Now, if we add 1 to our vertex point, making that 2, let's see what that gives us. Well, this gives us positive, this term right here, I've already drawn the line, gives us positive 1. Positive 1 squared is 1. 1 times 4 is 4 minus 10.56, which is 625, which is negative 6.56, yada yada yada, you know. So we go over 1 and we get the same point. This is starting to create our basic parabola shape. Alright, now let's solve the second stage. So now we're going to go 2 over. Now this isn't on our graph, but when it gets to up here where we're going to plot it, I'll add some boxes. So since we're going 2 over, we're going to be adding negative 2 to 3 to our already negative 3.375 vertex, and now we're at negative 5. This simplifies to negative 2. Negative 2 squared is 4. 4 times 4 is 16. So now we have 16 minus 10.565. If we simplify this even more, it's positive 6.5625, yada yada yada. So we go all the way up here to 246.5. I'm gonna make this mark and then I'll zoom up just a little bit, see if I can get this. There it is, way up there, and if my camera stand will allow me. There you go. Way up there. So now all we have to do is draw a line down to there. And right here, here's your little trick. You can see that's just 2 boxes over because we've gone 1 in each direction. And so now that we've gone 2, we can just go 1, 2, 3, 4. Mark that one. We can complete that without having to redo all the stuff. Now what we're looking for is for our original equation to be equal to 0. So if we look, where our y value is equal to 0, which is on the x-axis. Right here is 5, and right here is, that's a pretty bad curve, but that comes in about right there. I have a very unsteady hand. But if you were to graph this with, say, Desmos or a graphing calculator, it would directly come across negative 1.75 and negative 5, both because they're on this side of the y-axis. That is also how we would get our answers, negative 5 and negative 1.75, if we were to graph it. Okay, so now we're going to determine the number of solutions based on the discriminant. The discriminant in this case is the square root of b squared minus 4ac. And I'll show you why right now. In the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. If that is negative, it will have no solution because you cannot find the square root of a negative. Therefore, there are 0 answers if it is negative. If the square root is positive, then it will have 2 answers because you can add it and subtract it. If this is 0, then subtracting 0 and adding 0 gives you the exact same thing. Therefore, there is only one answer. That is why we call this the discriminant. I have three separate problems, all doing one of the 3 different types of discriminants. We just simply have to plug them in. When doing the discriminant, you do not have to use the square root sign. In fact, that is purely not required. I can't come up with the word. It's kind of late at night. So b, which is 8 squared plus, 8 squared minus, minus 4 times a, which is 4, times c, which is 4. 4 times 4 is 16. 16 times negative 4 is minus 64. 8 squared is 64. Minus 64, which is 0. If we plug this in to the rest of it, and since the square root is 0 is 0, no matter what b or a is, it will still have the same answer. No matter what, it doesn't matter if you add or subtract, it will still be the same answer. Over here, we have, my problem. We know from earlier in the video that my problem definitely has 2 solutions. If we plug in the discriminant, don't need that. 27 squared plus, minus 4 times 35. 27 squared is 729. Minus, because there's no other subtraction, minus 560 comes out to a positive 169. 169, and we know from our problem that that has 2 solutions. Over here, let's plug these in and see what we get. 2 squared minus 4 times 10 times 30. Ooh, we're going to get a big number. So right now we have, 10 times negative 4 is minus 400. 10 times negative 4 is negative 40. Negative 40 times 30 is negative 120. And of course, 2 squared is a little old 4. This gives us a negative number, and when we plug it into the rest of the stuff, you cannot find the square root of a negative number, therefore the number of answers is 0. This is the discriminant of the quadratic formula. Thank you for watching my video, and I hope I explained it good.